This is the supplementary video for Qffusion. This paper presents Qffusion, a novel dual-frame guided framework for portrait video editing. Specifically, we first specify editing requirements by modifying the start and end frames with professional software such as Photoshop. Then we propagate these user-given fine-grained local modifications such as age, makeup, hair, style, and wearing sunglasses. We consider a design principle of animation for editing to deal with portrait video editing. That is, we train a video animation network as a proxy task, which can perform portrait video editing easily by applying edited start and end frames as references during inference. Specifically, we propose a grid arrangement QGA scheme to fuse the reference frames and key points into a joint feature under a quadrant grid fashion. The fused feature is then fed into the denoising UNet to encode driving correspondence and temporal clues for intermediate frame generation. Further, we propose a recursive inference strategy quadrant grid propagation QGP, which is capable of stable arbitrary long video generation. Our QGP inference gradually replaces reference images at the current inference iteration as the newly generated frames at the previous inference iteration. At each inference iteration, QGP makes the intervals between each sub-image in the foregrid representation the same, leading to a more even temporal sampling than naive inference. We conduct ablation studies to validate the effectiveness of the key design of our QGA and QGP inference. Our QGA uses a starting frame and an ending frame as references to constrain the generation of intermediate frames, which achieves consistent performance improvement over A and B. A QGP can achieve more stable and temporal aligned results than the naive inference. Our Qffusion can perform fine-grained local editing, such as modifying hair, style, and wearing sunglasses. We compare our Qffusion with recent state-of-the-art video editing methods, TokenFlow, Codef, Re-render a video, and NEV2V. Codef sometimes suffers from inconsistent ID issues. See style editing. TokenFlow and Re-render a video cannot edit hairs, since text-only editing methods cannot capture detailed appearance information directly. NEV2V often faces the degradation of editing appearance. Besides, we use Control-Next SVD for comparison, which integrates ControlNet into SVD for controllable video generation. However, it yields inferior performance to our Qffusion. More importantly, all existing methods cannot generate arbitrary long videos. More video editing results are presented. Our Qffusion can also perform whole-body driving. It achieves better results compared with 3 task-specific methods: Dream Pose, BDMM, and Reproduced Animate Anyone. Our Qffusion can also deal with jump cut smooth. A jump cut brings an abrupt, sometimes unwanted change in the viewing experience. Our method can be used for smoothing these jump cuts. Qffusion can generate arbitrary length videos via the proposed recursive QGP inference strategy. Here we provide 500-frame portrait video animation and editing examples. Compared with the naive inference method, our QGP inference can alleviate the error accumulation issue greatly. One may wonder whether our method can deal with potential inconsistencies between the edited first and last frames. When such inconsistency occurs, our method can present interesting transition results between them. There still exists some limitation. Our Qffusion sometimes faces unsatisfying cross-ID animation result. When the driving landmarks come from a different person, the shape information cannot be well aligned between different persons. Thanks for watching.